Hello, everybody. Today we are going to talk about the integration by parts. So let's see our presentation I have prepared for you. Integration by parts, whenever we have integral questions and it is difficult to solve the given question by using the regular rules, regular properties, or up to now what we have studied, and we are not able to solve the given question. So there is a special method which is called integration by parts. The formula for the integration by part is equal to here as you've seen. U times dv is equal to uv minus integral v times du. Now, if we want to prove or if we want to show how we get this formula, it's coming from the product rule. If you remember, for the product rule, whenever we have two functions, function u and function v, its differentiation with respect to x will be u times dv dx plus v times du dx. So this is our formulation, or in practice, if you remember, we talk about u times v derivative is equal to derivative of the first function times the derivative of the second function plus derivative of the second function times the first function itself. So even you can say, I mean, some books use, u times v derivative is equal to u times v prime plus v times u prime. Both of them are acceptable. There is no problem. So in this question, when we look at here, u times v prime plus v times u prime we have used, that is this one we have used. And then if, as you see here, the denominators are common, so if you multiply the both sides by dx, so it will, dx will be eliminated, cancel out, and then we will have only this part. So differential u times v is equal to u times dv plus v times du. After this step, if I just remove this part where v times du, the other side, positive expression will be negative, and when it goes to the other side of the equation, so we will have duv minus v du is equal to u times dv. And if we rewrite this, u times dv equals differentiation u times v minus v times du. After this step, if we integrate the both sides, this is the integral symbol, integral u times dv is equal to integral the right side here, and then integral u dv is equal to, by using the integral rules, if you remember, we said before, f of x minus g of x dx as an integral. This could be expressed by using this property. What was it? It was integral f of x dx minus integral g of x dx. So we can separate the given function as integral. And then when we look at the left side here, so we will have the first integral minus the second integral. And we know that like a inverse operation, d and the integral symbol will eliminate itself, since integral is the anti-differentiation, anti-derivative, d is the differentiation. So anti and the normal one will eliminate each other. And then we will have just uv. uv minus integral v du will be our formula. Guys, there is something that's important. Whenever we solve the question, which part we are going to call as u and which part we are going to call as dv, it's very important. If we select the suitable one, the right one, we can solve the question easily. Otherwise, the solution will be very, very long. So it will take our time. So it will be not a good solution method. So based on our experience as math teachers, we recommend to our students, if you want to call something u in this integral, so we say LIPET, which means L is abbreviation for the logarithms, and I is for the inverse trigonometric functions, P for polynomials, and E for exponential, and T for trigonometry. So if there will be in the integrand, which is u times dv, if there is something in terms of logarithm, we give the priority to say to you that function. So I can say that if I draw an arrow, so logarithm is the first. If there is no logarithmic part, if there is trigonometric, inverse trigonometric, we call it as u. If not polynomial, we call u. If not exponential, if not, and then the trigonometric one. And also other thing, whenever we have polynomial things here inside, if something is easy, after differentiating it, the result will be 0, then we prefer that one is as u, and the other part, which is dv, is easy to integrate. Something it's easy to integrate, we prefer as dv. And then the formula uv minus v du. Now, if you look at the first example here, the question is x times cosine of x dx. So we do not know, by using the regular properties, rules, formulas, whatever we have. So for that reason, we may think integration by parts. What was the integration by parts? It was this formula, u times dv equals uv minus v du. So which one will be u? When I look at my question, this is polynomial and this is trigonometric. And the priority from left to right, if we say, if there is logarithmic, no. Is there any inverse trigonometric? No. Is there any polynomial? Yes. So x is a polynomial function. So for that reason, I call u is equal to x. And then remaining part, which is cosine of x dx, we are calling it is equal to dv. So one more time, the rule is this: something in this order, logarithmic, inverse trigonometric, polynomial, exponential, and the trigonometric, from left to right, if something appears firstly, we call that one is u. So as you've seen, x is a polynomial function, and we call it is u. So for the u, we always take the derivative. So our integral is, in terms of x, so this is dx. So we are getting the derivative with respect to x. So du is equal to dx. You know why du is equal to dx? We normally say d dx u is equal to d dx on the right side x. So this will be du dx, and derivative of x with respect to x is 1, and then if you do the cross multiplication, du is equal to dx. So it's directly right. If u is equal to x, du dx, we can say, but this is the way how we get it. And the second part, dv is cosine x dx. So what are we going to do? We are going to take the integral. So on the right side, if I integrate this, so integral of dv, it's always v, no excuse, always. And on the right side, what is the integral of cosine of x? So if you remember the integral rule, the result is sine of x. And then we know what is u, we know what is v, we know what is du, so we can implement our formula. Now, x times cosine of x dx, which is, this is u, and this is dv, equals u times v. So u was x. U times v. What is v? Sine of x here. And then minus integral v times du. V was sine of x. So we have written here, du is dx. And then it's very simple to integrate what is sine of x dx. Sine of x dx is, as we know, cosine of x. So, and then this is over. So we can say that integral of sine of x, if you remember, let me write it, integral of sine of x dx is equal to negative cosine of x plus c. And then this negative and this negative will be positive cosine of x. Since we don't have the boundaries, lower and upper limit, we always integral constant c. So that's the answer of our question. Okay. If we continue solving another question, which is ln x dx. So when I look at the question, which part could be u? Which part should be u, actually? So let us remember the L stands for the logarithm. Bingo, logarithm is here. Ln x is logarithm, So I'm going to call u is equal to ln x. And then I will take the derivative of this. Du dx is equal to d dx ln x, which is du will be 1 over x dx. Why? We know that ln x derivative is equal to 1 over x. And then the remaining part, which is the dx. So dx is equal to dv, we say. And then if we integrate this part, so integral dv will be v, integral dx will be x. And then we know what is u, what is v, what is du. If we substitute here in the equation, we will get an x times x minus the v is now x, du is 1 over x dx. When I simplify x and x, it will be 1 dx. So integral of 1 dx, we know that x plus c. So the answer of the question, ln x times x minus x plus c. That's it. Okay. Right now, let's talk about this question. Okay, so let me solve this question here on the left side so I can explain maybe better. I don't want to follow the PowerPoint directly. So let me say integral x squared times e to the power of x dx. So what am I going to say, guys? Do you know that we said LIPET from left to right? Is there any logarithmic? No. Is that inverse? No. Is that polynomial? Yes. Where? Here. This is the polynomial function. So I'm going to say that this polynomial function will be x squared, and the remaining part, which is e to the power of x dx, will be dv. And then the rule says that always take the derivative of the u. So if I say d dxu equals d dx x squared, I can say that this will be du dx is equal to derivative of x squared with respect to x will be 2 times x. And then if I do cross multiplication, du is equal to 2x dx. Right now, let's keep it here. And for the second part, we always take the integral. So integral e to x dx is equal to integral dv. Integral of dv is always v. You know, derivative of v is 1, so there's here 1 times dv, so derivative of v is 1. And integral of e to x dx is e to x itself. We know this thing. And then if I remember my formula, so let me clean this part. How was the integration by part? We said that integral u times dv is equal to u times v minus integral v times du. So in my question, what is u? It is x squared. What is v? E to the power of x minus v, which is e to the power of x times du. So what is du here? We just said it. Du is 2x dx. 2x dx. And then what am I going to do? So I can take this 2 out, which will be x squared times e to the power of x minus 2 times e to the power of x times x dx. But now, how can I continue? So it's clear that I can't solve this question by using the normal way. If you remember the L'Hopital rule, we were implementing the question when the conditions are satisfied, L'Hopital rule again, again, and again. So same thing we have for the integration by parts. So let me call this integral just I1. So let me solve it here separately. E to x times x dx. So what will be this? So if I remember again, LIPET, is there any logarithmic? No. Is there inverse? No. Polynomial? Yes. Why? This is polynomial. So I can say that u is equal to x and remaining one e to x dx. So this is equal to dv. And then if I differentiate this, du dx, it will be d dxx, which is 1. And then this will be du is equal to dx. So on the right side, integral e to x dx, e to x, this is integral dv, and then the integral of e to x is e to x, and integral dv is v. So for this question, if I write, let's go down, if I write u times v, x is u, and v is, where is v here, e to x, minus integral v, which is e to x, times du. So du is dx. Oh, I got it. Excellent. Why? E to x dx, we know it's very simple integral. So this will be x times e to x minus integral of e to x dx is e to x. So right now we have solved this part, which we call this is I1. If I substitute my result, so it was here, remember, this was our solution. So the answer of my question will be x squared times e to the power of x minus 2 times result of this integral. And result of this integral we just calculated, x times e to the power of x minus e to the power of x. Since we don't have the boundary, so we always have the integral constant c. And if we rewrite this, so it will be x squared times e to the power of x minus 2x e to the power of x plus 2 times e to the power of x. Just I distribute, negative 2 times this and negative 2 times that, plus c. And after this step, what can I say? If I take e to the power of x common parenthesis, x squared minus 2x plus 2 plus c. That's it. This is the answer of my question. So in this question, what did we see? We can implement, we can apply the integration by parts again and again when the conditions are satisfied. Okay, so we may continue, but since this is a demo lesson, so I may stop here. There are also other questions. What am I going to do? Okay, let us imagine this is our real lesson. Okay, this is even in a classroom lesson, online lesson, or this is tutoring lesson, one-to-one lesson. After explaining these things, I'm going to give a chance to my student. I will tell him or her, right now, it's your turn. This is your question. E to the power of x times cosine of dx. So what will be answer of this question? So right now, the student, let's say, is going to use his or her pen or tablet, and on my screen, student will write, and while the student is writing, I'm going to see how he or she is solving the question. Whenever the student has a problem, I'm going to just kindly stop the student and say that, my dear, this was the rule, so there's a calculation mistake, you should use this, you should use that. So I'm just going to remind him or her the rules and what should it be done, and students will get the result by itself. If student is not going to get the result by himself, by herself, I'm going to explain one more time. It's fine. And then this is the solution of this question. If we say, now there's also for integrating by parts, one practical way when we have one of the function is the polynomial function. The way is this. Let's have a look. It is called the tabular integration, works for integral of the form of f of x, g of x dx. So f of x is something could be differentiated and result will be 0. For example, x cubed, derivative is 3x squared, another derivative 6x, another derivative 6, derivative of 6 is 0, and so on. And gx is integrates repeatedly. So let's see example, x squared e to x dx. So how to solve this? By using the tabular method. So I'm going to say that x squared, when I differentiate it, result will be 0. So the second derivative of x squared is 2x, derivative of 2x is 2, derivative of 2 is 0. That's it. On the right side, the other function, which is e to the power of x, I will take its integral. E to the power of x integral, e to the power of x. Again integral, again integral, again integral. E to the power of x is a spatial function. Integral of e to the power of x dx is e to the power of x plus c. So when I finish this, so plus, minus, so alternate. And then we are writing the result like this. The first term on the left corner with this, x squared times e to x, minus 2x times e to x, and then plus 2 times e to x. So we are not writing the 0. And then this is the answer of the question. For sure, we are going to add plus c. Why? We don't have the lower and the upper boundaries. So this is called tabular form. So this is, it's easy to do, but can we use this? Can we use this way for all kind of questions? Unfortunately not. So if there is something, when you integrate it, and then the result will be 0, as you've seen here, okay, we can implement, we can use this method. Otherwise, we can't use this method. Okay, now, This is the normal method. The same question by using our integration by part classical method. So x squared, so we can say that this is a polynomial, and we will say that u is equal to x squared, as you see in here, and the remaining part is e to x dx. We will say it is dv. When we differentiate the du dx will be 2x, and when we do cross multiplication, we will get this, and then integral of dv and integral of e to x dx will be v is equal to ex, and when I implement the formula, I will get the result, and then I will see that here there will be this, but I can solve this directly, so I have to implement integration by part one more time. When I use the second time, here I will call this is u, and e to x dx is dv, du is dx, v is ex, and then when I substitute, I will get the final result. Okay, if I use the tabular method one more time, x cubed sine of x, I know that derivative of x cubed at the end will be 0, x cubed 3x squared 6x negative 6, 6x 6 times 0, and plus minus plus minus. So integral of sine of x is negative cosine of x, integral of negative cosine of x, negative sine of x, integral of negative sine of x, cosine of x, and integral of cosine of x is sine of x. When I finish this one and this one, 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 when we multiply, so we are going to get this final result. Okay, so now I want to give you just one homework, and when you finish the homework, please email me and I will check and give you feedback. Your homework question is this one: integral x times cosine of x dx. So I want you to solve this question and email to me. I hope everything is clear. If there's something, please feel free to ask me. I'm going to share with you this board, these writings as a PDF file, and I will send this as an email. Okay? Do you have any question? No. Okay, thank you. Have a good day ahead. Bye-bye. Take care of yourself.